Hello everyone, welcome to this video on linked list using Java. Now here in this particular video, we'll be talking about and we'll be going through the basic understanding of what exactly is this data structure called linked list. What is linked list, why it is used, what are the different types of linked list that we have in a coding paradigm, and what are the different operations that we can perform on linked list. This is going to be a short video, but we are going to cover a very important and some detailed topics in this particular video. So yeah, without any delay, I think we can let's get started with this. First, we will try to answer the question that what is exactly linked list. So some of you might have confusion, some of you might have read at few places like linked list is a data structure that has two elements, right, or two parts in it. One is the node. Okay. There is a node, there is and then another is a reference, the link to it, right? Now I will not explain you from the general perspective or general definition. I will try to give you an analogy on the trains. Now I assume that most of you have sit or have traveled in the train. Now if you see here on my screen below, there is a train, right? In this train, there is a engine, or you can say the head portion in the front, right, that drives the train ultimately. Similarly, in case of linked list, we have three concepts. Okay, first is a node, second is the data, the third is the link or reference, whatever you want to call it, the fourth is the head. Okay, now some people or some books, some articles also mention about the tail as well, so we'll cover that aspect as well. Now these are the five terms that we need to understand and see how exactly and what exactly they mean in case of linked list. So you can say that linked list is a data structure. It's a place to store some data. Now every data has its own properties. There is no fixed manner of store all the different types of data that are present in the world. Each data has different relationship among themselves. Okay, each data might not, some data might not have relationship among them, but some data might have relationship between them. So in order to store the data that has some relationship, that has some reference towards the two other part of the data, we use linked list. Now what do I mean by reference and how exactly do we store data in linked list? That is what we will try to explore in this video. So see, if you assume this as the bogie of the train, like the one compartment of the train. Now this compartment is being divided into two parts. The first part is what carries the passengers. Now let's call the passengers as our data. The other part of the compartment has the reference, or you can say the link to the next compartment, right? So why? Because this has the link, because we want our compartment to be connected to the next compartment, and we want this compartment to be connected to the next compartment, so that the train is complete, so that the train will run together, right? So you can see here, this compartment is being linked with this compartment, this compartment is being linked with this compartment, and so on till this main engine. Now in case of linked list, the first node, okay, or the starting point of the linked list is also called as head. In the train, we can call head as the engine, the main engine that drives the train. Okay, and each compartment, you know, is being divided into two parts, right? Now head is the portion of the train that will help us to locate the linked list. Okay, so the head portion will help us to find out where exactly the linked list starts from. Okay, so any time when we have to locate the linked list, head portion will come into the picture. So after head, we have all the nodes connected to it, and each node is being divided into two parts, that is data and the link. So this each of them is called a node. This bogie or this compartment is a node. So I hope you have got the idea about the node. There can be infinite number of nodes into the linked list. Okay, and each node is being divided into two parts. One part contain the data, another part contain the link for the previous or the next node. Just to make sure that each and every compartment is well connected, right? This compartment has the reference for this particular node. This particular area has the reference to this particular next node. This area has the reference to this particular node, and so on so forth. Now there is head that we have seen the node, we have seen the data, we have seen the link, we have seen the head. We have not seen the tail. So you can assume, right, and obviously this is very obvious, that if this is the head, this portion must be the tail. Now what is good about the tail? The good thing about the tail is that no linked list or there is no next node to the tail. First of all, it means that there is no node that will contain the reference of this tail, right? So that's why it is called the tail, right? It is the last node of the linked list. Okay, so I hope you get the idea about the linked list. Now how exactly the data is stored? See, the data is stored where we have sitting the passengers. Now this can be a goods train where the data is stored in the form of goods, right? This can be a passenger train. You can assume the passengers is the data, right? So this is how the data is being stored in the beautiful data structure called linked list. Now your aim would be to perform certain kind of operations, okay? And there are different types of linked list. Depending upon how they are structured, how they what are their properties. Okay, so depending upon them, there are different types of linked lists that are present in this. So let's try to explore the different types of linked lists, because I think you have got the idea about the basic understanding of the linked list. So coming on to the types of linked list, the first type of the linked list is the singly linked list. In case of singly linked list, you can assume it's a simple train that most of us has traveled into. It's a simple train that where each coach connects to the next coach in one directional only. Let's say you are traveling from Delhi to Mumbai, right? So the train will go from in one direction only, right? This is the train that will go into only one direction from Delhi to Mumbai. So when the train goes from connects one coach to another coach and in only one direction, that is a classic example of singly linked list. You can also call it as and understand it from the single track train, right? The train cannot come back, it can just go into one direction, right? So these are the compartments that we have. This compartment stores the data, and this part of the compartment stores the link or the reference for the next node. Okay, so this is one type of the linked list, that is singly linked list. Try to talk about the other type of the linked list, that is doubly linked list. So see, doubly linked list is a very simple concept to understand. Okay, here now you can say that the compartment structure has changed a bit. Okay, instead of having only two compartments, we now have 1, 2 and 3 compartments, or you can say a coach is being divided into 3 parts. Okay, the first part of the coach will contain the data. Okay, as you can see, as like normal. The second part of the coach was containing the pointer, the link, the reference to the other coach, right, to the other compartment. But this time it is containing not only one link, but it is containing 2 links. Okay, one link to the left coach, another link to the right of the coach. So here what we can see is, let's say this is one node of the linked list, this is another node of the linked list, and this is another node of the linked list. Here let's say we store the data 1, 2, 3. This is the data that is stored in each of these nodes. Now this particular part of the node will contain the pointer that is to the left of, that is located to the left of left of this particular node. Okay, that is the pointer referencing to this particular node, and this part of the node will contain the pointer that is referencing to right node. Okay, similarly this node will contain two addresses, one of the left pointer, another of the right pointer of the right node. This particular node contain two pointer, one for the left and another for the right, but this, since this being uh, the rightmost pointer, this will not have the right pointer, or if it has, it will point to nothing, right? Similar case is here. This particular, it has some data, let's say it has the data 4. This particular part of the node will point to the left pointer, but there is no left node, so it will point to null. But the right part of the node, right part, or you can say the other part of the compartment, will contain the address to the right node. Okay, now you can assume this in terms of train, where you can in singly linked list you were only allowed to move in one direction of the train. That is, you can only go from coach A2 to A3 and A4 and A5 only in this one direction. You can go from one compartment to another compartment, another in only one direction. Okay, but in case of doubly linked list, you can not only go in one direction, but you can also come back to other compartments. For example, you can go from A2 compartment to A3 compartment. Okay, and you can come back from A3 compartment to A2 compartment as well. But previously, in case of singly linked list, if you are going from A2 compartment to A3 compartment, you have to go from A3 to A4 or A4 for A5. You can't come back to previous compartment, right? But in this case of doubly linked list, you can come back anytime, or if you want to move forward, you can always move forward, right? Now, why this is helpful? See, first of all, this will help us in certain kind of operations. We will see in coming slide that what are the different operations that we will perform. Let's say the ticket checker officer wants to check the ticket, but this compartment is busy with something, right? The people have not onboarded for this A3 compartment, so, and the ticket checker is on A2 compartment. So what the TC will do, it will go to A3 compartment first, and it will check whatever people are there. They will check he will check the ticket of them. Then he will go to A4 compartment, and after one or two stations, when people from A3 compartment have been boarded, more people in A3 compartment have been boarded, the TC can come back to A3 compartment and check the ticket for them. And that's how the ticket is being checked. And from this analogy, you can understand how doubly linked list work. So there is only one difference, only one difference between singly and doubly linked list. Singly linked list is connected to the next node. Okay, and every next node is connected basically, and you can only move in one direction while you are searching for something. Okay, or while you are going forward from one coach to another coach, you can only go in one direction. But in case of doubly linked list, you can go back in one direction and you can come back in another direction as well. It means both the movements from left to right and right to left, both the movements are quite flexible. Okay, so that is the concept of doubly linked list. I hope you get the idea about doubly linked list now, and let's try to move forward to another type of the linked list that we have. The circular linked list is very easy to understand. You can assume that the circular linked list is something like a train that is moving on a circular train track. Okay, why circular linked list is special? Because in terms of linked list, the last coach or the last compartment connects back to the first, okay, forming a circular route. That's what it means. For example, this is the linked list. Now if these are the three nodes in the linked list, this particular node, right, this particular node will not have the reference to anything. But what we are saying is, in case of circular linked list, this particular node will have the reference to this last node or last compartment. It means each and every node has some address, has some reference, has some link, right? And all of these compartments, all of these nodes are connected among each other. Okay, so this is a different concept from the previous linked list that we have seen, right, where the first node was not having any reference. It was just the head node that symbolizes that the linked list is starting from that point. But here, in case of circular linked list, the first node will have the reference to the last node of the linked list, and that's why it is called a circular linked list. Right. I hope you get the idea about the different types of linked list. Now what we will explore is the different operations in linked list. So there are multiple operations that we can perform. Again, all the operations depend upon our understanding, depend upon our use case, the problem that we are trying to solve using the linked list. These are the 4 common operations that we perform in linked list. Okay, and I have also created an analogy how they would be pronounced, how they would look like if we were doing in terms of train, if we were talking in terms of train. So in first operation is insertion. Insertion means adding a new coach to the train. Okay, you already have your linked list present, and this is, let's say, the head of your linked list. Okay, this is how your linked list look like. Now you want to add a new coach, you want to add a new node, right, in your linked list. Now there are multiple ways you can add your node into this linked list. Either you can add it in the front of the train, or you can add it in some place between the train. The new coach can be added in the front of the train, that is just before the engine, or it can be added anywhere between any two compartments, right? Or it can be added in the end of the train, right? It may be the last compartment that is being added, the last node of the linked list, right? So these are the 3 types or 3 places where this insertion operation can be performed. So there is a certain kind of steps that we have to take for performing this insertion in linked list as well, right? We will talk about them in future videos about the details of insertion in the linked list. Now let's talk about the deletion. Let's say you want to remove one coach. Let's say the coach is now dirty, the coach cannot be used more, the coach condition is not that good that can be operational. So what we want to do is, in this train we want to remove a particular coach. Let's say I want to remove this particular coach, right? You saw, right? I remove this particular coach. Now there are multiple types here as well. You can remove the coach from the end, you can remove the front coach, or you can remove the coach that is situated in between. So there are different types of deletion that you can perform in a particular linked list as well. But deletion means removing a node, or in terms of train, it means that removing of a particular coach. Now let's talk about the third type or third operation, that is traversal. Traversal, you can assume that let's say you have your train, you have your seat at A2, right, but you are standing at A4, right? Now you have to travel from A4 to A2 compartment. This particular compartment is, let's say, A3, and there is another compartment behind this is A4, right, and this compartment is A2. You have your seat in the A2 compartment, but right now you are standing at A4 compartment. So from A4 compartment you have to move to A3 compartment, from A3 compartment you have to move to A2 compartment. Since I told you that this is a linked list, this is a train, that all the coaches, all the compartments are connected, right? So now all the compartments are connected, it means that you can traverse from one node to another node to another node, right? So that is what we call as traversal. You can take an example of TT, right? The ticket checker. The ticket checker guy, the officer, has to travel from one coach to another coach, checking all the tickets of all the passengers, right? So that's what the traversal means in linked list, right? The fourth operation, I would say, is searching. Let's say the police comes into the train and they are looking for a particular passenger that has done some mischief, right? And we want to look for a particular passenger in different coaches. They have their coach number as A2, right? The police got the tip that the coach number of the thief or the mischief guy is A2. Now they are searching from one node to another node whether the particular data is present or the particular passenger is present in the coach or not, right? So finding a coach is an operation in linked list, right? Is a searching operation in linked list, where you search for a particular coach, where you search for the data of a particular coach as well. So I hope you get the idea about the 4 operations that we have in case of linked list. So yeah, that was my ultimate aim for this particular video, that I wanted to give you an idea, complete idea about the basic understanding of linked list, so that it is easy for you to understand and to grab the concept of linked list. So yeah, these are some social media handles that you can follow us. And thank you very much, I think, for watching this video. And I hope you have learned a lot, and I hope to see you in the next one.